In this part of our review on solving equations and inequalities, we're going to look at equations that have variables on both sides of the equal sign. So this is a little more advanced where the variable shows up in multiple places, but we're still dealing with our same order of operations, and we're still following it in backwards order. So if I had something that had both adding and subtracting, like 2x minus 4 equals 4x plus 6. Then I need to get all of the variables together because there's some variables on each side. And remember, I want to end up with x equals something when I'm finished solving. I can't do that if there's still x's on both sides. So here there's a couple of ways to follow through this, and I want to talk about both of them. The first one is to put the x on the left. And the second is to keep x positive. Both of these are valid. I generally lean toward keeping x as a positive number, but I'm going to show you how this problem would work both of those ways, and they are both absolutely valid. There's not a right or wrong way. So if I have 2x minus 4 is equal to 4x plus 6, then I know that I need to get all the x's to the same side, and I want to, in this case, put them on the left. So I'm going to subtract 4x to get rid of all the ones on the right, and then that leaves me with negative 2x minus 4 is equal to 6. Now, since I put all the x's on the left, that means I can't have any constants on the left. This now looks more like a two-step equation with variables on one side. So I need to add 4 to get rid of this subtracted 4. And then I get negative 2x, the 4's cancel. And on the right I have 6 plus 4 is 10. Then as a last step, I need to divide by negative 2 because that's my coefficient of x, and it will make the x be by itself. And I get negative 5. So that's keeping all the x's on the left, and what that made me do was divide by a negative. If I keep x as a positive number, then I don't have to do that. So I have slightly different challenges. So each one has their own intricacies to worry about. Neither is better or worse. So in this case, I'm going to keep my x's positive, so I'm going to subtract 2x, and then I'm going to be left with no x's. I have negative 4 equals 2x plus 6. My next step is, since my x's are now living on the right, I need to get rid of the negative 6 that's over there, or the 6 by subtracting 6. So now on the right, I'm left with 2x, and on the left, I'm left with negative 10. My last step in this case is to divide by a positive 2, which still gives me the exact same answer of negative 5 equals x. And then by convention, we write the x on the left in our solution. So as a reminder, if we read this negative 5 equals x, it's the exact same as reading x equals negative 5. So I would write my final answer x equals negative 5, like that. This is going to be slightly different when we get to inequalities in a later video, because if I had something like negative 5 is less than x, it looks different when I read it left to right. So reading it this way is negative 5 is less than x, but reading it this way, it says x is bigger than negative 5. So for that, I would write my answer x is greater than negative 5. All right, so next example is going to bring in multiplying and dividing. That's where these get a little bit trickier. So if I have something like 2 minus 2x over 3, remember that's the same as 2/3 x. I'm just writing it different ways so we can get used to seeing it in different forms, equals 4 plus 3x. So there's multiple options, again, of how to work this. One way is to deal with adding and subtracting first, the way reverse PEMDAS tells us to. So let's do that first. I've kind of identified for me that I want my x's to live on the right, because that's where I'm going to end up with a positive amount. But again, you could put them on the left. It doesn't matter. So I'm going to try to get all of the constants off of the right side. So I'm going to do -4 and -4 because I've identified this is where my x's are going to live in the next step of the problem. So now I have -2 minus 2x over 3 is equal to 3x. Now, fractions can be intimidating and scary, so what we're going to do is get rid of this denominator. That is not the only way to handle this, but that's what I'm going to do here. So to get rid of a denominator, we can multiply every term of the equation by that denominator. So we're going to multiply by 3 on both sides of the equation, and every term multiplies by 3. So this -2, this, and this all get multiplied by 3. So now I have -6 minus 2x, remember the 3 over 3 cancels, equals 9x. Now I need to get the x's together, so I'm going to add 2x, and I get -6 is equal to 11x. And then finally I would divide by 11. And I end up with an answer that may make us, well, let me write it the right way around. So I get -6 over 11 equals x, which I'll write my final answer as x equals -6 over 11. That answer may make you a little uncomfortable, but it is a totally valid answer, and it's part of why it's so important that we know how to properly solve equations. Because no matter how intuitive and good at solving equations you are, if I gave you this equation, I can pretty much guarantee that you're not going to just come up with -6/11 is the answer without having a method to get to it. And even if you could, there are infinitely more complex things that you wouldn't be able to do. All right, so a different way of approaching that, which this is the way I would recommend doing it, is the way I modeled it here. But we could have, at the beginning, gone ahead and added fractions to whole numbers. So at this step, -2 minus 2x over 3 is equal to 3x. Instead of multiplying everything by 3, which is probably the simplest and best option, we could have gone ahead and put the x's together and done plus 2/3 x on both sides. When we do that, we're left with -2 equals, but now we need to add 3x and 2/3 of x. You may be tempted to write that as 3 and 2/3 x. We don't want to use mixed numbers, so mixed numbers, as we're working through an equation, are bad. We don't like them because we can't do operations with them. The reason for that is 3 and 2/3 x. Remember that the word and stands for plus. So really 3 and 2/3 x means 3 plus 2/3 times x. And that's not something we can easily deal with our inverse operations because it's a combination of addition and multiplication, and they're all like twisted up together. So instead of 3 and 2/3 x, what we need to do is change the 3 into a number of thirds. So we don't want to write 3 and 2/3. We want to think of this as 9/3. That would be multiplying, remember 3 is 3 over 1. So that's the same as 9/3 plus 2/3. So I would say this equals 11/3 of x. Then I would follow through with multiplying and dividing, so I could do times 3 to get -6 equals 11x, and then divide by 11 to get -6 over 11 equals x, and I get the same final answer that I got before. So again, there are multiple paths through a problem. There's at least 4 or 5 other sequences you could follow through this, and they're all valid as long as you do them correctly. All right, and then to close out this video, I want to look at one with different fractions. That one is the one that trips people up the most. So let's look at 1 over 2. So 1/2 plus x is equal to 3/4 x minus 7. So on this problem, We have fractions in both the constant part, so the constants have a fraction, and we have fractions in the x part. So that makes it really difficult to do any of our inverse operations from the beginning. Instead, what we're going to do is create what we call a least common multiple, or LCM, and get rid of all of the fractions. So very similar to what we did in the last problem, we're going to multiply all four terms. So remember that terms are pieces of math information separated by plus or minus. We're going to multiply all four terms by some number that both 2 and 4 go into. And the smaller that number, the better. So the smallest number that 2 and 4 both go into is 4. So I'm going to multiply both sides by 4. If the numbers were 3 and 4, I would have to multiply by 12, because 12 is the smallest number that 3 and 4 both go into. So when I multiply this, 4 times 1/2 is going to be 2. 4 times x, remember we're distributing here, 4 times x is 4x. Over here, 4 times 3/4 x is 3x, and 4 times -7 is -28. So now there's no fractions, and this becomes a much simpler problem where we're just moving terms around using our opposite operations. So now I would do -3x. Since I brought my x's to this side, I also need to do -2 to get rid of this 2 that's on my x side. I can do that in the same step like this, or in two separate steps like we've done in the last two problems. 2 minus 2 cancels. 4x minus 3x is 1x. 3x minus 3x cancels. -28 minus 2 is -30. Remember that since they're both negative, a negative and more negative makes a bigger negative number. Like pretend that you owe $28 and then you owe another $2. You now owe $30. Okay, so that's where we're going to close out this one. In the next one, we'll talk about distributing.